This is the same thing I did yesterday, so if you saw it yesterday or if you like it, see it again. That'll get started. I'm Hobbit, I'm a Prius addict. And this is actually a sort of less technical talk than I'm accustomed to doing, but the idea is to sort of be accessible to the general public. My background is sort of hobby electronics all my life, with a vehicle interest here and there. By trade, I've been a network security goon, sort of getting away from that a little bit. The Prius is one of those things that just brings together lots of neat technology, so it became sort of a hobby since I got the car in early '05 or so. Once I started looking into it, it's just like this rat hole path of all kinds of things to read about. I had the typical, I had like a Isuzu Trooper. I was sort of in that mindset of I need a big vehicle to haul stuff, and you know, it would have been lovely to get a hybrid minivan, but back in that time there wasn't anything available. So, and I have no regrets whatsoever about landing on the Prius because it's turned out to be a great freight hauler, a fun project, and if I can't get a 100 mile per gallon box truck for all the lighting gear and stuff, it'll do. These are the flyers that I once again forgot to bring in, but you've probably all gotten them anyway or seen the website. I'll bring some in after this if we need them. So I go around to these car shows and energy shows, whatever, and just kind of like spread the word about Priuses. Everybody comes up and they want to know, how to get higher mileage out of their cars. If I've installed extra batteries, the answer is no. What's really developed around the Prius is this really strong community. There are several Prius forums. There's a Clean MPG with a lot of Prius owners. There's lots of places to go for information. So anybody who's shopping for a Prius, they go off and find these websites that give them all the information. So to give back to that community that helped me out when I was shopping, anytime I discover something or do a hack to the car or whatever, I try to write a page about it and stick it up at the website. At this point, if you Google for Hobbit and Prius, my stuff is like always the first thing on the list, which is really gratifying. So again, my strength has sort of been finding out what the car is doing in the stock system as opposed to trying to add to the stock system. From that knowledge, plow that back into here's how to drive the car better. To do that, I need to put in some instrumentation that Toyota didn't give me, like a tach for the engine, like a battery current meter. Things that tell me if the engine was running or not, because it's so quiet and smooth, it's really hard to hear sometimes. So, this and the electrical wiring diagram from Toyota and all that service manual stuff you can download sort of became my reading, bathroom reading for quite a while. Now there's the Bentley book out. The Bentley book is really cool. It's a reprint of a lot of that stuff. There's this glossy section in the front, which is called the New Car Features section. And that's where Toyota sort of describes how a given vehicle works. And in this one for the 04 and up Prius, they go into a lot of the differences between the older Priuses and the newer Priuses and all the engineering improvements that were made. So that's a really good read because it just goes pretty deep into all these systems and tells you how they work. And once you get some instrumentation in there, you go out and sort of say, I'm going to try this different method of driving, and the results start speaking for themselves. That was one of my early test runs where 70-something miles per gallon was like unheard of on the forums at that time because people weren't really into it. And I thought to myself, I'm going to go kick butt at the Tour de Sol in a couple of months where they're going to have an MPG competition. And little did I know at the time there were already people working with 3-digit boundary on the MPG averages. And I met a bunch of those guys at Tour de Sol that year. It was really fun. Got to know each other, got to meet Wayne, got to hang out with Mike Dabrowski. I realized they were pushing ceilings that I had to dream about. But meanwhile, the car stayed in a somewhat torn apart, not this bad state over the summer. Everybody thought it was nuts. You guys had like wires hanging out of the dash and proto boards and scopes sitting in the footwell sometimes.
How did you figure out how to get them apart? Did brakes on get it apart?
No, the dash panels snap out pretty easily. They're easy to remove. You just sort of use a straight arm pull so you can't come too far and bend it away, because that's where you snap the tabs. So as you can see, the dash panels, all these little bit panels just sort of pull away from the car, and maybe 1 or 2 screws and everything just pops out. So later in the year, there's this thing back in Boston called All Wheels. It's an alternative transportation show or whatever. And I got this idea, well, I've got this good at taking the car apart and sort of detailing how it works. Why don't I do this for the show and make it kind of an educational exhibit? So I came up with this concept of the naked Prius. There's a whole page about that. So I took a bunch of stuff apart in the car, and this wasn't the layout, but I just had things labeled up. I had, you could see inside the battery box. I had a clear cover for the inverter, and then people, thought it was pretty cool. And this was one of the first bigger car shows I had been to, and I stayed out on that lawn in the hot sun for 2 days straight, doing nothing but answering questions for people who came by, handing out information. It was just flat out, and I did not get any time to walk around the rest of the show and see anything. I was like, wow, there's all this interest in this car and what I'm doing with it and what the potential is for people. This was back in 285 gas or something like that. And at the end of the day, the car took best in show, which utterly floored me. I did not expect that. Just with this barefoot weirdo ripping his Prius apart and then handing out all this techie documentation. I guess they liked it. So in general, what is all the stuff about hybrids? Why are they good? Sort of the running title of this whole thing. The slide is somewhat dated. You can sort of see the timeline. First one to hit these shores was the Honda Insight, little tiny two-seater, very purpose-built for high MPG, and it is still the king of MPG. What is it? 7 years later. It's aluminum frame, very light, really efficient engine. Honda did a pretty good job on it. A year later, the first Priuses hit these shores, but the Prius was actually around in Japan since 1997. They didn't bring it to this country until it was sort of time-proven. You talk about first gen and second gen Prius, there was actually a 0th generation of Prius in Japan, which was, used different batteries, had some slightly different body style. And then the other automakers sort of followed suit and kept bringing in more things. The Americans started getting into the game. And I sort of see the timeline stuff. Now, what do you suppose this little guy in the corner here is? He's not on the list. That's the Toyota Estima. It's a hybrid minivan, like I was looking for back at that time. It is sold only in Japan for the last 5 years or so. It gets over 40 miles per gallon US. It's got all-wheel drive with an extra electric motor in the back, and it's not here. Why don't we have these here? You tell me one soccer mom, small contractor, delivery guy, or whatever that would kill for a vehicle like that to do their daily rounds. Toyota will not bring that to this country for some reason. They could do all the safety mods necessary in their sleep. They do that all the time. And they've seen all the questions go by on the forums. Where is the Estima? Why don't we have it? And there's no answer. Go figure on that one. But of course, when people think about hybrids, they think Prius. This is the canonical shape of what people. If a cartoonist draws a hybrid, they draw one of those. I sort of refer to it as the invasion of pods. Not too many of these are seen, but since I'm from Cambridge and Boston, we have quite a few of those running around. A lot of dedicated owners. And you can see that's a sedan style. And then they moved to the hatchback for 04. And the hatchback is a totally kick-ass design. You have so much fun with it. In fact, I've got a whole web page up about all the loads I've put in my car because it's been so much fun. That's a full 6-foot step ladder on top of everything else in there. Those light cases weigh about 150 pounds apiece.
That code is NWH and 20, what is the code is that?
NHW11, NHW20. That's the two models, two model numbers from Toyota.
But it don't decode the...
No, it's just a model number. So for those that prefer a more modernized sedan, there's the Toyota Camry. Of course, if you really want to go top end, there's the Lexus models. This is Gilles Lebel. He actually owns this one. He's the guy that sold me my Prius. He used to be at Westboro Toyota back home. One of the few car salesmen that's really dedicated to what he believes in, and is really just upfront and honest about hybrid ownership. And he calls himself the CO2 Terminator, and he'll bend your ear all day about global warming. He's a really fun guy. I think he's moved on to other things from the car dealership, but in the meantime, he was using that position there to push hybrids into as many hands as he could. He did a pretty good job on it. Camry's nice. I got to drive the first one in 06, test drive at Tour de Sol. Very smooth and nice, except I could not find warp stealth on it to save my butt. Going down the road, the Altim's out now. Got to drive one back home. The sort of the mild hybrid trucks are out now, but they're not really true hybrid. They're sort of belt alternator starter until they actually start putting the 2-mode in there. What GM does with these trucks, though, they they have a onboard AC generation, so the contractors load them for work sites. They can run their power tools off it. Not too clear on what VW is doing. And then, of course, there's the Chevy Volt, which, the fabled Chevy Volt that we're supposed to see out. On Friday, that engineering person from GM gave us sort of an update on what's going on with the Volt. They say it's on track for 2010, and it's going to be out, and it's going to be killer, and they're very confident about it. I can tell. Then, of course, well, we had a couple of large SUVs from GM over at the FPG competition. But meanwhile, this was from back last November at the New England Auto Show. I went down there and this thing was sitting up on the show floor, and just for a lark, I walked up to the booth person and said, "So give me a little demographic here. I don't want to beat you up here, but what is the customer profile that buys an Escalade?" She brightened right up and said, "Oh, it's all the Detroit Pistons buy them." And I'm like, "What sport is that?" But literally, while there's some arms of GM that is doing pretty well in the engineering department and working on stuff and having dedication, there's another marketing arm to which hybrid is just a buzzword they slap on the side of a vehicle so they can sell more. And the Detroit Pistons can think, "I'm green," while they're getting 16 miles per gallon. So it's basically just a bling box. So that's, sort of, so the idea is to sort of warn the independent auto tech that hybrids are coming down the road at them faster than they think, and they should get up to speed on them and start learning about them. So some of the stuff now is from this training course that's like, I don't know, 10 or 12 hours of Prius slides at this point, and a lot of other stuff. It's hard to get these guys out of their shops. To get them out of their bays and into a seminar setting is really difficult, especially when you're trying to charge them money. So, but once we get them in there, we start going into some of the differences and why electric motors are good and why they should learn about electric motors. And some really obvious comparisons. You've got the efficiency the highest efficiency gas engine is maybe up around 30%. So 2/3 of the energy you put in as gasoline is gone as heat. Electric motors, they're pushing past the 95% boundary now with modern motor technology. Electrics, you have all of your torque right at the bottom end from 0 RPM, just right off the line. They work in all weathers with no concern about warm-up or thermal management. And they require almost no maintenance. They just sit there and work and run and whatever you want to do with them. And they don't have all the icky fluids you got to maintain with the gas engine. But, so the gas engine has the advantage of range and our current infrastructure, and the electric motor has the efficiency. So what a hybrid does is just combine them a little bit. Here's a chart for the Insight. So you can see the Honda Insight engine is a little tiny 3-cylinder lawnmower engine. It doesn't have a whole lot of torque and power by itself, but especially down at the low end here for takeoffs and things, you add in the electric motor, you get this nice little boost of torque. So now you got the engine and the motor sort of pushing together, and then over the whole power range, you get a little bit more out of that 10 kilowatt IMA motor. So that's, it's a nice little chart of how a hybrid system, even a small one, can help cars' performance. And of course, once you've got an electric motor in the system, you can also use it as a generator and have the car push in. And that's what regenerative braking is all about. Instead of burning some gas to get going and then squandering all of that as heat in your brake rotors by the time you get to the light, you can recapture some of that energy into a battery and then play it back for your next takeoff. So your energy profile overall, even with starting and stopping, is much lower. And it's, there's a lot of misconception about regenerative braking sometimes. People think the brakes actually do something to generate power. That's not true. It's just right back through the drive lines to the drive motors of the car, turned into generators and sending that energy to the battery. I have 81,000 miles on my Prius. My brake linings, the brake pads on the fronts are like factory thickness. They're just not wearing at all because I'm so seldom on those brakes. And that gives one other problem, is that if they sit out for half a day when it's raining out, they tend to rust up. And what happens then is, as you transition from regenerative braking down through about 8 miles an hour in the Prius, and the motors aren't turning usefully enough to generate power, you transition over to physical brakes, and suddenly it's like you're grabbing sandpaper with all this rust, and that's why people report in the forums, my brakes are grabbing. They get down, just as they're coming to the intersection, the car falls on its face, and they're like, what's wrong? That's the answer. Look inside the Prius motor. This is the main motor. Last year we had that whole transmission demo I brought, since I'm trying to cut the weight this year and continue west for a road trip after Hybridfest. I didn't bring any of that stuff. This is the motor we didn't bring, but that's the main push motor of the Prius MG2. You know, the rotor's about a big around, not especially large. The windings are something, you can drop that whole thing into a milk crate and just fit in there. And yet this unit can produce 50 kilowatts, which is the same amount of power as the gas engine can produce. So now you can see you've got this nice little compact unit, same power output as that big clanky thing full of icky fluids next to it. It's another advantage of electric motors, they can be very small. You know, and of course, in the tech training thing, we start going into all kinds of motor facts and figures, and most of this is over the auto tech's head already. They're starting to glaze over. But, you know, if they really want to learn about three-phase motors and get all this material available for them. What's interesting is this picture is actually from one of the Argonne papers. There's this set of reports where Argonne and Oak Ridge, the National Energy NREL-related labs, were taking Priuses apart down to like unwinding all the motor windings to see how the heck the Japanese had packed so much wire in there, and all these engineering feats that they thought were impossible were just right there in the Prius. So they were doing all this analysis, and there's a bunch of good papers out there that I point to. But you know, it's your tax dollars at work here, producing nothing but these papers. And then, as far as like the whole Freedom Car project and partnership for next generation of vehicles, there's nothing that I see from that lab work that's actually on the road today. They have a couple of prototypes that are interesting, but it did not seem to plow into the American car making industry as something to really compete in the market. So the first thing an auto tech needs to be able to do is to use the car. And if an auto tech comes in and sits down in the car in front of a customer and is then unable to drive it, that looks bad. So they have to get used to the power states of the car, the push button thing. They haven't seen that before. Other cars are starting to get the push button start now, so they're getting a little more used to that. Beamers and things. But the shifter is funny in the 04 not Prius, that momentary thing. So you have to just basically get their knowledge level up to that of the customer so they can handle the car correctly. And you know, from that standpoint, Toyota still did a pretty good job, even though the control syntax is a bit funny. You get in, you put it in D, you go. And you really just don't have to worry about it much. Some people are disturbed by the fact that the engine shuts off like before you arrive at a light, but if you think about it, did a steam locomotive idle? No. So the new model of thinking is now don't use the engine, don't run the engine unless you actually want to bring meaningful power out of it. So just let it shut down unless you're really going to use it. The first thing a lot of people ask about the Prius, of course, is the battery. You know, how long does the battery last? How much is it going to cost me to replace it in 4 years or whatever? Well, the answer is it lasts the life of the car or better. And it's got a whole little computer in there with the battery whose sole job is to manage charge in and out of that pack and keep track of the whole string of cells and make sure everything's happy in there. The big secret to battery longevity, these nickel metal hydride cells are not only fairly robust cells, but they're used in a particular way. If you're familiar with your typical power screwdriver, you use those all the way down. You use it until you cannot drive that last screw, and then you recharge the battery. Well, at that point, you've done a deep discharge event with that battery, and that gets into what's called cell lifetime, cycle lifetime. You can only do that so many times to a given battery. And also, if you overcharge them too far, you're going to get into chemistry changes. But within a narrow range, and in the case of the Prius, it's 40 to 80% of the pack's rated capacity. You can do as many microcycles in there as you want without changing the cell chemistry, and that's exactly what Toyota does with this. They constrain that charge, so when you see full on your display, it's actually only 80% or so, 79%. When you see empty, it's only down to 40%. There's still plenty of leeway left there if you really needed to use it, but the car will not let you use it. So you get about half the pack's rated capacity, but that's enough. That's enough to be an energy bounce pad for stocks. It's enough to get you up and down hills with a little bit of energy recapture. It's not sized to push you for the whole day of errands. Inside the battery, pretty easy. It's just a bunch of interlaced plates with separators. There's not a whole lot of liquid electrolyte in here. It's not like if you punctured a 12-volt lead acid battery, you get this trickle of acid coming out. It's fairly dry in here. When Mike and I opened this up, there were a few droplets of electrolyte sort of clinging to the inside. Didn't get a big gusher of leakage. And took some on my fingers, kind of rubbed it around. It felt sort of soapy, like you'd expect a strong base to be. And it didn't sting me, or I didn't eat it, but it's just potassium hydroxide. It's very simple. I just washed it off in the sink, no problem. So not only is it environmentally benign, it's not particularly hazardous stuff. It's really hard to actually get far enough into a battery to get it on your hands. And where the battery is in a Prius, it's between the rear wheel strut towers. It would be really hard to crash the car hard enough to damage that battery. It's inside a steel box. It's very well protected. But of course, an auto tech is already familiar with a bunch of safety topics. They deal with flammable liquids, heavy things, sharp things, rusty things all day. They have to be pretty aware of safety in the shop. Now we add the factor of high voltage batteries and the fact that if they did do the really wrong thing, it could kill them. We pass out 1,000-volt gloves at the training sessions, teach them how to use them right, teach them a little bit about the tools needed to make sure that there's no high voltage present before they go to work on something, and to basically keep their wits about them and not become our safety poster boy here. This is actually an instructor who should have known better. We just happened to catch him in a bad moment. He was like leaning on a pack explaining something else entirely unrelated. But here he is wearing a watch next to a live pack. So he didn't get electrocuted or anything, because he wasn't actually on the contacts or down on the sides here, but he came close to that. Emergency responders also need to know a lot about the safety aspects of these cars, and all of the automakers that have hybrid vehicles out have what's called emergency response guides up on the net, free for the taking, just in PDF format or whatever. I highly recommend reading them, even for cars you don't own, because it's a nice comparison. Not only do they teach you all about the safety aspects of the cars, including airbag squibs, where fuel lines run, and also now where the high voltage batteries are. It's a nice technical overview of the car, so it's just a nice thing to get this nice picture of how to deal with a crash situation. Some good sites that have more information about it. Bottom line is that airbag squibs, the explosives that make the airbags inflate, and fuel lines are much more dangerous than any of the high voltage stuff. In the shop, we're at a crash site. The crash sites tend to do what's called stabilize the vehicle by getting some stuff under it so it doesn't rock on the wheels or anything. When you go to lift one of these cars, you have to be careful. Just like you have a fuel tank in the back with fuel lines running underneath and then up to the engine area, now you've got the battery in the back, the high voltage lines, and that's also the engine area. So it's, anywhere there's an energy supply situation, it tends to run under the frame rails. So you have to be careful when setting up a lift to not crush that stuff. Okay, so now the techs know how to work safely on the cars and get it up on the lift and then get it into the shop. What are they going to do on the car? Well, the answer, unfortunately, is not much. The Prius in particular is proving very reliable. The maintenance schedule from Toyota is change the oil every 5K, rotate the tires, and that's it for up to about 100,000 miles when you start worrying about plugs and fluids. So obviously, even the independent auto tech is not going to be doing a whole lot on those cars unless there's an actual problem. But at the same time, we want them to use the right fluids, make sure they get the right oil in there, get the right oil level. Oil overfill is a common problem with the Prius, so we can work them against that. And a bit of information about different kinds of transmission fluids and things. Street wisdom is that you really should change the tranny fluid somewhere around 50K, maybe 40 or 50K intervals, just to get like the early wear metals out of there, out of the first the factory load, and keep it clean. So that's sort of a disappointment. You come into these seminars thinking, oh, we're going to make all this money on hybrids now. It's like, well, the hybrid owners aren't going to come in that often, but certainly for regular car stuff or any kind of damage or routine maintenance, people do not have to go back to Toyota. And not only am I trying to teach the mainstream public this, but also the auto techs. We had this great idea for the seminar. At the end of the seminar, we give them a big vinyl banner that says, "We fix hybrids." They can put it out on their shop, but that hasn't actually happened so far. So then it takes kind of a step back and say, okay, here comes the real technical meat. If you ever get into the whole hybrid thing, this is what you need to know. Different hybrid topologies, of course. We have the series in parallel. With the series, we don't have any series hybrids out on the road yet, unless you count like the big diesel locomotives. Engine does nothing but turn the generator to generate power for the drive motor and also possibly to charge a reserve battery. And in fact, if you take away the pony motor and the generator there, what's left? That's your electric car. You arrange some external way to charge the high voltage battery, you just drive around on that all day. Advantage here is it's full electric operation. There's no transmission really required. The motor can just have all the torque off the bottom and come up to the speed needed. Parallel hybrid, that's when the engine and the motor generator are linked as a single unit. This is how Honda does all their systems. They spin together, so if you want to push the car in electric power, you have to drag all the engine metal around at the same time. The advantage of the parallel hybrid is you can downsize both the engine and the electric motor because they can combine forces and push the car together when high acceleration is needed. So that's why, one of the reasons that the Insight's so efficient is you don't really use the motor unless you really want to go. Toyota took a look at this. He said, how can we get the best advantage of both types? And they came up with something called the series parallel hybrid. And now you're starting to wonder, okay, this looks really complicated. How can it be so reliable? How are these transmissions not breaking down? Well, first of all, the engine sort of indirectly provides power. A good percentage of it goes straight to the driveline, so you've got a nice efficient mechanical path from engine to wheels. The rest of it gets caught by this power split device, which really is just pretty much a differential. You've got power coming in via one shaft and leaving via two. It just splits out. The rest of it is caught by this motor generator. And these two motor generators can power each other and in any direction. So that remaining power from the power split device can be sent over to help the big motor push and or charge the battery. And when you're doing regen, of course, you can push the car solely with MG2, so you've got your nice silent operation, and that's what also captures your regen. So by just switching the power flow around this, it sort of like closes the loop and makes this into a real transmission. So you've got part of the path to mechanical, part of it is electrical. You're still shunting power around this thing at a different settable ratios, and the computer sorts out everything you need to do there. If you take apart a Prius transmission, this is all you find in it. You've got your two electric motors, you've got your single planet, nothing ever disengages or shifts or changes state, or you don't have any clutches or bands or hydraulic fluid, pressure valves or anything like that in there. It's just this, and it just stays meshed and spins all the time. Somebody asked about this damper clutch thing yesterday. It's not really a clutch, it's just a vibration absorber. If you had some big shock load to the system, like you hit a rock or something like that, it would just absorb a little spin between the engine and the transmission. So normally you just treat it like a shaft. So is that fluid? Well, there is transmission fluid in this, but it's only for lubrication. It does not transmit power like
no, how transmission mechanically, or with two fans blowing fluid against each other like an
No, there's a little pump at the end, the outer end of the transmission that pulls fluid out of the bottom and just sends it down this concentric shaft, lubricating bearings along the way. It's a very low flow, just a little bit of a trickle just to keep things
I'm talking about the damper. How does it transfer power from one side to the other?
Oh, it's basically a spring clutch. It's like a limited slip differential. It's just a friction piece with some springs in it.
I got a question for you. What's the difference from the plug-in Prius? What do they make? Change they make to the drive on?
Nothing. Nothing at all. They don't get into this at all.
I'm talking about the Toyota version now.
I have no idea. No, I haven't seen a spec on it yet. Anyway, yeah, that's why the likelihood of a tech actually needing to jump in here and do any service on this is very, very slim. I think Arts Automotive in California has done one, and they actually have wrote up a nice page about it. This is what it looks like physically. If we had the thing here from last year, we'd have these parts to take apart. This is from the guy that brought one to Lacey, Washington. But that's it. He's holding the planet carrier. It goes down into the hole there, and that connects into the engine side, and that's it's all the gearing you see, and the rest is motors. When it's all together, it looks like this. This is Toyota's standard trade show cutaway that you see everywhere. You have your big electric motor here, small one over there, planetary gear set in the middle, and it all just kind of fits together and runs concentrically. During driving, the user doesn't have to worry about any of this because the computer is doing all this math many times per second and sorting out everything based on driver input, speed, temperatures. It takes all of this into account. Speaking of the computers, they're tucked up here under the right side of the dash inside the cab out of the weather, so they're very well protected. And yet all the connectors to them are very easy to get to. You just drop the glove box out, take it away, and there's all the plugs that go into those computers. It's very easy to backpin them and pull out a signal to look at. So needless to say, I've spent a lot of time under here. I'm one of these weirdos that likes to take the O-scope out cruising on a Saturday night so I can watch the waveforms. I'm not going to say too much about the Prius engine itself, other than that it's very efficient. Take this little guy and park it at like 18 or 1900 RPM across the Ohio flatlands, and it will deliver the goods all day, 60 miles per gallon and 60 miles per hour, so maybe slightly more under optimal conditions. That is the steady state running capability of the car, and people who are getting their 42 miles per gallon are just doing the wrong thing with their foot. And we'll get into that in a minute. One feature of the Prius engine, though, is in the 04 model we added this little coolant bottle. And that's a little vacuum flask, just like a coffee thermos, dual wall thing that's very insulated. When you shut down the car, a little pump moves hot coolant from the engine right into that tank. It can hold about 3 liters of antifreeze keep it hot for maybe 2 or 3 days, depending on ambient temp and winds. And then when you go to fire up the car again, now that the block's cooled off, the pump moves fluid back into the engine block, right around the cylinders and head, and right around where the combustion area is. So this gives you a nice preheat. It also keeps the early emissions way down, because when you run a cold engine, the emissions are horrendous. And if you can get the cylinder walls warm, because it's a heat engine, it depends on heat of the surroundings to actually run efficiently. So you get sort of a jump on all that. You can also add a block heater to get even more heat into that system from the wall. So the only plug-in conversion I've done on my car is adding a block heater, and the plug is under the hood, so that doesn't really count as selective propulsion. The thermos bottle sits right up here under the nose of the car. You take the fender liner out. So obviously it's the first thing to go in a frontal accident. The one that Mike and I cut apart, though, is it was all mangled up. It was from auto viewers, but it still had its vacuum. We went to saw it open. As soon as he breached the hole, it was like it sucked in all this air. So it was a pretty robust unit, even though it's in a vulnerable position. Well, let's talk about engines in general. This is probably the part you all came to hear, is the efficient driving bit. These animations are from kevin.com, by the way, and I highly recommend looking at all of them up there. The guy's done a really amazing job of just showing how all kinds of engines work, including big old aircraft radials and things, cool stuff. There are 2 major sources of energy loss in these engines. One is you're sucking air in past this mostly closed throttle flap an awful lot of the time. So that's a huge pressure load, and this piston has to go down, fill that whole volume against this flap, and it's trying desperately to move all that air and not being able to. So that really is quite a bit of energy loss. And of course, then you're also sliding this piston up and down with rings that are pushing out against the cylinder walls, and that creates a lot of friction. That creates even more waste heat. So what's the fix for that? We're kind of limited because almost everything has these piston engines. Well, answer A is to open the throttle flap a little bit more and let more of that air in. And answer B is to not slide quite as often, because the more you work against the resistance, the more energy you're using to do that. And this is counterintuitive, because most people think, well, if I open the throttle, I put my foot down, the engine's going to rev up. So it's a little bit, you have to think about this a little bit differently. And the bottom line is you want to get into your high gears as early as you can while you're driving, and you're keeping the RPM in check using your gearing. So you're using the road load to keep the engine down to low RPM, but working hard. High torque, low RPM, that's the key to this. This is something called a brake-specific fuel consumption map. And what's done here is you map engine RPM, rate of turning, against the engine load. Shaft torque, how hard it's really working. The red line is anywhere along this line you get the same output power. Power is torque times RPM. So if you low torque and high RPM, it's still the same horsepower. And then now you can see that you can get the same amount of horsepower at a high RPM but low torque. And if you see these numbers, they go up as you work down this chart here. Here is high fuel consumption, and here is lower fuel consumption. This looks sort of like the contour map of a hill. What you want to do here is climb the mound. You want to be as high on that hill as you can get. So here I am coming out to Hybridfest 06, tooling along, turning 1800 RPM in the engine, my big old tack here, going 66 miles an hour across the Ohio flatlands. And the quiz for the auto techs at this point is, what is MG1 doing? They're supposed to have studied the nomograph and the gearing and all the stuff about how the transmission works, just as an exercise. Toyota's version of that same VSFC chart, this is from an SAE paper where they're talking about Prius throttle control. And the Prius, in particular, we have the really nice advantage that we divorce the user from throttle control completely. Your foot tells the hybrid ECU, please may I go faster. And the hybrid ECU says, well, we need a little more power out of the engine control, and the engine controller eventually opens the throttle with an electric motor. This gives the advantage that the throttle control can be done in the most efficient way because the user doesn't really have that input. So what Toyota does in Prius is they try to stay outside of this thick black line all the time. And you can see that the first thing you do, right down at the bottom of 1,000 RPM, get the throttle open, get high torque going at that low RPM, and then from then on, it's all about RPM. Just how fast you let the engine spin to provide power. So you can now think of the engine almost as a constant torque device at that high torque level. And because of that disconnect between the user and the throttle, they can just do that. So I have a vacuum gauge in my car, which sort of shows you how hard the engine's working. It'll sit there sort of at a high level, idle level, all of a sudden just like snap down, which means the throttle just like suddenly opens to that high torque state as I put my foot down. So as I'm tooling along at 66 miles an hour, I'm being a little bit of a bad boy because I'm going kind of fast there. Starting to get into the bad territory here. Obviously, for most vehicles, slow down on the highway. That'll save you a lot of fuel right there. Every trucker knows this, whether or not they do it. Somewhere between 55 and 65, you start to really ramp up. It's an exponential curve, and the resistance goes up. It's the cube of your speed, not the square. That's the energy required overall to push the car through, push all that air out of the way. So obviously, slowing down on the highways is one of the easiest things to do. This is not recommended. Bob is actually here. He made it here yesterday. He was over at the show. This is his sort of hack-up picture of the MPG enhancer. The hypermiler community, as you probably know, we're doing a lot of damage control the last couple of weeks from that stupid AAA article where they were talking about all these dangerous hypermilers around crafting trucks and doing all this nasty stuff. Well, the community has never endorsed close drafting or any closeness of vehicles at all, because following distance is really key to getting good mileage out of the car. It allows you to predict everything. You don't get that much benefit from a truck unless you're tucked in as close as he is, and you never want to be there. If you've ever played around with drafting, you realize that you have to respond instantly to any tiny speed change that the lead vehicle does. And since you're not even in communication with it, you have no idea what the guy's thinking, what he's responding to in front, just don't do it. It's not worth it. Following distance gives you other very clear advantages. These are from the amateur scientist site. These animated GIFs just kind of show how many more cars can go through a given point when they do a nice smooth zipper merge and just keep going pretty much at a speed. This is more like, Route 93 into Boston in the morning. Everybody just kind of chokes up in bunches, and then they have to fight each other and arbitrate, and they're notably bad at that. The nice smooth zipper merge, well, put it this way, I love construction sites on the interstate because they give you tons of warning, they've got all these signs, a couple miles out. At a half mile, I can start my glide as I see the thing coming. And I can look at the traffic behind me, in front of me, next to me, figure out the relative rates of motion and say, okay, I'm going to drop into this hole right here, I'm going to be down to 50 miles an hour here. And by the time I reach the construction site, I'm down to its safe speed that they post, using no fuel in the entire process. And that's what by giving myself that huge buffer, I can just play around in there and just do the right thing. Another really nice perk of coasting, being able to coast into things, we need a lot more of these, right? This is a standard roundabout. There's a lot of interest in transitioning traditional intersections into roundabouts because it really does cut down on congestion, allows traffic to do 4 things at once instead of only 1 thing at once or 2 things at once. If you look at, this is where cars have to cross, these hollow circles. Look at this huge bunch of them in the middle of a typical intersection, right? This is why you have to have the light and make a whole bunch of people wait because there's all this confluence. In the rotary, there are none of those hollow circles at all, and only 4 points where cars have to merge and cross. So these are a huge win. The other big win about rotaries is they're coming. and you can start your glide at the right point to arrive at rotary speed just as you enter it. So you may have to stop and yield for another car, or maybe you can just keep drifting around. And of course, the hit from having to stop is much less than going, is it going to turn yellow, is it going to turn yellow, and then getting nailed by it, which really sucks when you're going on 50 miles an hour along these major roads. So traffic light's bad.
Where did you find that graphic?
That is out of one of the rotary roundabout advocacy sites I found. I think it's one of the AAA thing. I recently updated my link farm to point to it. So if you go there, you can find it. I saw that and I said, I have to make a slide out of this. And this happened last week. Okay, so you want to coast nicely in these situations when you can. The best thing to aid coasting, of course, is tire pressure. This is what happens to tires and to Goodyear integrities if you run them at Toyota's recommended pressure. You get all this edge wear. And so anybody who's going to try to give you the counter argument about, oh, if I pump my tires up too much, I'm going to get center wear. Well, here's an underinflated tire, right? And you can see how rounded this part is at the top, even in this underinflated tire. You'd almost expect that since it's so rounded, why did the center wear along with? Right? There's your evidence right there that's all on the sidewalls. When, as the tire goes under the contact patch, all the stress comes down right out here at the edge. And then when you try to corner, the sidewalls are leaning more. Right? So you really want to get those tires up to the sidewall rated pressure or better. The 44 PSI of these and a lot of the other replacement tires for the Prius, that's the design pressure they were designed to run at. That's why it says that on the sidewall, 44 PSI. The other thing to note is, what is cold? Is it -5 degrees wind chill, or is it like this morning? It's fairly nice out. Cold pressure can vary, the temperature can vary that much, and you get about 1 PSI for every 10 degrees Fahrenheit of temperature change. So if I pump my tires to 44.0 PSI and in a winter morning and I drive to my folks' house in Florida where it's 70 degrees, what happened? I'm well north of 50. Does anybody consider that unsafe? No. These tires have like a factor of 5 or more safety factor, just like many other things that have modern designs. So by going to 50 PSI or whatever, you're still well within those safety limits, and now the tires will wear evenly all the way across. You won't get this differential tread wear, and your cornering will be tighter. You get much better response in the rain. There's several articles now about police departments testing these things on their Crown Vics. They found that higher pressure was much better for performance.
Yes, Hobbit, that's exactly what I found. I was really worried about inflating my tires so high because I was at 47, 49. And I found that driving in the rain was so much more solid. And that's what I was really worried about. But it was like, man, this car handles better.
Yeah,
with that higher
there are people that still think if you go to like 44.3, your tire's going to explode. And they don't realize that not only do you get higher pressure, the higher you run them, the less they actually heat up when they're driving. That you get out and feel the tread, and if you're running them soft, you'll actually get a more of a temperature differential. And when you hit a bump, you hit all the chuck holes out of these roads, you get shock loads of pushing 100 PSI there, and the tires can take it. So really, the tires are just amazing. I mean, they do an amazing job considering what they have to run over these days. All right, so let's summarize a little bit. For eco-driving, which is the term that that is now catching on like wildfire all over Europe. I think it originated in the Netherlands, where people have really good clue about fuel economy and saving resources, but it's kind of propagating over Europe, and I hope it propagates to here. They actually teach this as part of the driver's ed now over there, where everybody's happier with smaller cars. They don't worry about speed and power so much. So high torque, low RPM. There's a lot more manuals over there in Europe than there are here. People know how to drive them. Predict everything you can, and I don't know if you saw my little green mods list that the Hybridfest folks gave me yesterday, but at the bottom I had this little rant about how since hypermilers are paying attention both forward, backward, and to a bunch of gauges all at the same time, their job is nothing but driving. They've got to be the safest people on the road, hands down. Just, anybody who says the guy on the phone is safer than the hypermiler is just fooling themselves. Tire pressure, obviously, slow down on the highway, keep the vehicle well maintained. Obviously, if you've got dirty air filters and crappy old oil in there, it's not going to be nearly as efficient. You can possibly use the latest oil that the manufacturer of the vehicle allows you to do per their spec. And then, of course, braking technique, which I didn't really talk about yet, but the idea with braking techniques is to use them as little as possible. Yeah?
I'm using now synthetic oil in my possession
Yes.
instead of whatever oil I use. I do my oil change every 5,000.
Yeah, that's fine.
I
I use
recommend to everybody who has it.
Mobil 1 530 in mine. I might go to 0-20 in the winter when the viscosity is higher. Once the engine's up to temp anyway, the viscosity is pretty much the same. So yeah, braking technique, you want to not use them as much as possible. In other words, what a lot of us do is sort of between stop to stop, you want to calculate the energy envelope required to get you from here to there, which means here's your pulse, you get up a certain amount of speed, and momentum is a form of energy storage. And the form of energy storage that requires no conversion to accomplish the task you want, which is getting you to the next place. In a hybrid, proper braking technique tries to stay as much in the regenerative braking region as possible and not follow the physical brakes. And that sort of changes by car. In the Prius, of course, what you want to do is a very gentle braking event as long as you can hold it, because you keep your battery currents lower and you don't follow the physical brakes. If you try to pulse the brakes or brake too hard at the end, you're going to exceed the limits of what regen can give you. You're going to be pushing more than 100 amps into the battery pack, and at that point the physical brakes have to come in and help. In a panic stop situation, you're all physical brakes. But rest assured that the Prius, like all hybrids, has a full hydraulic braking system, just like any other car. In its normal operation, it's got these two valves sort of in the middle of the system that stay closed. And all the actual firing of physical brake pistons is done by computer, these solenoid valves. So, the hybrid controller and the braking controller have this conversation over the network all the time about how much regen can be supplied or how much regen is being supplied, and then if the braking controller needs to come in, it will. If you lose power or the braking controller screws up somehow, these two valves default to open. And now you've got a path straight from your master cylinder to the front wheel cylinders. So if your electronic by-wire braking system goes out, you've still got a mechanical hydraulic path to the front wheels, which are the big stoppers. So you still have unassisted braking power. A couple of other efficiency hacks. The Prius is one of the first cars that introduced electric air conditioning. They run this. I had to include this picture because the scroll compressor is just such a gorgeous piece of machining. And if you stare at how it works long enough to go after everything I tell you and get 100 miles per gallon segments. If you actually follow one of the sort of opening cavities in this, you'll see that it gets smaller and smaller and smaller, and eventually goes out a one-way valve in the middle, and that's how it compresses the refrigerant. The reason they run this off the hybrid battery is because you need about 2 kilowatts worth of power to get enough cooling in the car. Think your window air conditioning unit is about the same power level as that in a car air conditioner. So if you try to draw that from a 12-volt battery, you'd toast it with way too much current. So now we get this convenient 200-volt source. They run it as another 3-phase motor right off of that same battery. First-gen Prius still has a traditional belt-driven AC, so that's why its engine stays on when you want the AC. So what's coming down the road? Well, here's one of the early Cars plug-in experiments with the lead-acid cells and sort of home-built controllers and things. A lot of interest in plug-in hybrids. People really want to be able to do their under 40-mile commute in the day by pulling it out of the wall instead of buying gasoline, and still have the range extender of the gas engine when they want to do it. So, plug-in hybrids are not only coming down the pike, some of them are here, like yours, like the high motion packs. The big killer there, of course, is battery cost. So, it's got to solve that and get the battery technology where it needs to be. Hybrids are sort of, somebody put on Prius chat, half a pack a day, still smoking, we're still burning gas, just less of it. So it's kind of a bridge to the future. And I think the hybrids that are designed for speed and power instead of economy are not really helping the picture. They're catering to sort of the wrong market. But I guess, you get that market segment interested in the word hybrid anyway, and they start thinking about it. So this is the belly pan RAV4 EV. A lot of these are still on the road because they were privately owned, not leased. These things are massive 95 amp hour nickel metal hydride cells, and you can't get them anymore. They were made by a company called Cobasys, which I'll point out is an arm of Chevron. And not only can you not not get these from them, but the industry in general is being prevented from making these things by lawyers and patents. The whole market in large format nickel metal hydride batteries is locked up by this idiotic patent, where they're basically saying, well, we're not going to make them, and you can't make them either. And you know, when you think about it, when they're arms of oil companies, you really got to wonder what's going on. But you know, hopefully the consumers will speak up and start voting with their wallets and saying, you know, we really want you to just, you know, go or get off the pot and give us these large format batteries, give us, you know, better research in lithium chemistries. And, you know, that could get into the whole political rant, which could take the next 2 hours. Unfortunately, I seem to be at the end of my carousel, so thank everybody for coming and leaving with one last